In this video we are going to prove the Minkowski discrete inequality in a little L2 norm, where AK and BK are real valued sequences, so they take positive integer values and they map real numbers. We are gonna write the proof for this one. We take the norm, the little L2 norm of AK plus BK in the power of 2, and that is the sum. It's a discrete inequality from k equals 1 to n of AK plus BK squared. And that's going to be the sum k equals 1 to n AK squared plus 2 AK BK plus BK squared. I can split the sum. The first one is the little L2 norm of AK raised to the power of 2 plus 2 times the sum from k equals 1 to n AK BK plus the little L norm of BK to the power of 2. Now we can use for this term first of all that we have AK little L2 squared plus 2 times the sum k equals 1 to n, the absolute value of AK times BK plus BK little L2 norm squared. And for this sum we can use discrete Schwarz inequality. It's going to be AK little L2 squared plus 2 times AK little L2 BK little L2 plus norm BK little L2 squared. Now the right hand side is going to be AK little L2 squared, so it's going to be an identity. It's going to be the norm little L2 norm of AK plus little L2 norm of BK raised to the power of 2. And so far we have that norm of AK plus BK little L2 squared is less than or equal to AK in L2 little L2 plus BK in little L2 raised to the power of 2. And taking the square root on both sides of the inequality gives us that AK plus BK little L2 is less than or equal to little L2 of AK plus little L2 of BK. And that's the discrete Minkowski inequality in little L2. Where L2 is the counting measure, so it's AK, let's call it WK, from Z plus to R, such that the sum from k equals 1 to n of WK squared is finite.